What is the least positive integer n such that 149 to the power of n minus 2 to the power of n is congruent to 0 mod 3 to the power of 3, 5 to the power of 5, 7 to the power of 7. So, to solve this problem, I'm going to introduce something called the LTE lemma, or lifting the exponent lemma. So, to start, I'm going to give you a new function. So, let's let Vp of k be equal to the largest power of p that divides k. So for example, V5 of 250 is equal to 3, since 5 to the 3 is the largest power of 5 that divides 250. And so now, using this formula, the following is true. For any odd p, it is true that Vp of a to the x minus b to the x is equal to Vp of a minus b plus Vp of x. It is also pretty useful to know that for any odd p, we can set b equals to negative b, and then make plus plus, and then get a plus b and a to the x plus b to the x. You can also apply the LTE lemma to any even p, but we're not going to use that in this problem, so let's just move this to the top. So now first, let's notice that 149 minus 2 is equal to 147, and 147 is equal to 3 times 7 squared. So now let's apply LTE for p is equal to 3. And so, V3 of 149 to the n minus 2 to the n is equal to V3 of 149 minus 2 plus V3 of n. So now 149 minus 2 is equal to 147, and the greatest power of 3 that divides 147 is 1. Now we're also looking for the smallest value of n such that this divides 3 to the 3, 5 to the 5, 7 to the 7, and so this is equal to 3. So we have 3 is equal to 1 plus V3 of n, and therefore 2 is equal to V3 of n. Now doing the same thing for V7 gives us V7 of 149 to the n minus 2 to the n is equal to V7 of 149 minus 2 plus V7 of n. Now the greatest power of 7 that will divide 149 to the n minus 2 to the n will be equal to 7, and the greatest power of 7 that divides 147 is going to be 2. So we have 2 plus V7 of n. Now moving the 2 to this side, we get that 5 is equal to V7 of n. So now we have that factors of n include 3 to the 2 and 7 to the 5. And so finally, all we are left with is 149 to the n minus 2 to the n is congruent to 0 mod 5 to the power of 5. So now recall that if a number is congruent to 0 mod n, it is also congruent to 0 mod all of its divisors. And so we are also looking for 149 to the n minus 2 to the n is congruent to 0 mod 5. And so 149 is equal to negative 1, so we have negative 1 to the power of n is congruent to 2 to the n mod 5. So now let's make a table here. Let's look at values of n, and also values of negative 1 to the power of n mod 5, and 2 to the power of n. So if n is equal to 1, we have negative 1 and 2. If n is equal to 2, we have 1 and 4. If n is equal to 3, we have negative 1 and 3. If n is equal to 4, we have positive 1 and 1. And also, for n is equal to 5, we have negative 1 and 2. And so this cycle does continue. Now because it has a cycle of 4, we know that n is congruent to 4 is congruent to 0 mod 4. And so n is equal to 4c for some natural number c. And so we know that n must be divisible by 4, so let's add 2 to the power of 2 into the factors of n. Now finally, we apply LTE for p is equal to 5. So V5 of 149 to the power of 4c minus 2 to the power of 4c is equal to V5 of 149 to the power of 4 minus 2 to the power of 4 plus V5 of 4c. So as I mentioned earlier, we know that 149 is congruent to negative 1 mod 5. We also know that negative 1 to the power of 4 is congruent to 1 mod 5, and also that 2 to the power of 4 is congruent to 1 mod 5, and so this is equal to 0 mod 5, and so this must contain at least one divisor. And now remember that the highest power of 5 that divides 149 to the power of 4c minus 2 to the power of 4c is 5, since it must divide 5 to the power of 5. And so we have 5 is equal to 1 plus V5 of 4c. Now 4 is equal to V5 of 4c. And so the final factor of n that we must include is 5 to the power of 4. And so therefore, we know that the least possible value of n is equal to 2 to the power of 2 times 3 to the power of 2 times 5 to the power of 4 times 7 to the power of 5. Feel free to put that into a calculator, but I certainly am not. And so, we are done. Alright, thanks for watching. Hopefully you enjoyed, and hopefully I'll see you next time.